Okay, so as we discussed earlier, this was the things that we were talking about, right? So the unit conversions, we talk about this particular chart, and we did some conversions as well, right? So we talk about how to write the alternative answers and all these things, right? I think you can remember the conversions, people. So let's do the questions straight away, right? So I'm writing the questions. You can write down with me, and then you can do it as soon as possible, right? Let's do some two good questions, right? Converting a small one into a bigger one and bigger one into a smaller one, right? Okay, here comes the questions. Yes, Dilendya, your answer is correct, Dua. And you can convert 32 into a 2 to the power as well. And you can keep your final answer as entirely as a 2 to the power. Or the way that you have illustrated is also correct, Dua. No worries. So let me know the answers that you have made. So within another 5 minutes, I'm going to do the calculations, right? Yeah, I'll give you 5 to 7 minutes to complete the things. The first question and the third question are something very similar to the examples. And second and the fourth questions, that is something new to you. Not that is very new. When you know it, you can do it. Yeah, Dilendya, that's correct as well. Yes, Dilendya. Let me check. Yes, that's correct. That's correct. Yes. Third one, correct. Yes, Sanushi, it's, yes, first one is correct, second one is correct. Third one, okay, it's better you keep 2 to the power 6 as a number. That's correct. Third and fourth calculations are correct, Dua. So try to have that 2 to the power as a number for the third and fourth. Yes.
I reduced the volume. I reduced the volume.
Oh, but still it is being disturbed, Manika. They can hear. Stay there. Huh? Dilendia, yes. Yes.
Nothing seems to be the problem in its mouth.
That's correct.
I reduced. Is it okay now?
Yes, it seems to be. Right, and keep it on that table. Keep it on that table. And this is, what's the name? Kidney, yes. Kidney, it's not the first answer. I think a slight mistake has happened. To see whether.
Let's absorb the electricity the eel's sending out.
Second one is also going on with the same mistake, Dua. I think, hold on to yeah, I think you have messed up when you are converting 32 into a 2 to the power and 64 into a 2 to the power. Just check whether Dua. Right, people, let's do these things, right? So the first one is talking about how many kilobytes are there in 32 GB, right? So in the first one, we have to convert. Yes, yes, now that's correct. Kitmi, first one is correct. Second one still have some work to do. Ah, yes, that is correct. Yeah, third one, that's correct as well, Kitmi. So in the first question, the request was converting 32 GB into kilobytes, right? So the journey is going from kilobyte to megabyte and from megabyte to gigabyte to megabyte, from megabyte to kilobyte. All right, so what we are going to do is we are taking 32 as it is. To the gigabyte to megabyte conversion, we need 2 to the power 10. And to megabyte to kilobyte conversion, we need 2 to the power 10. So this comes with kilobytes. So which means 32 into 2 to the power 20 kilobytes. If we write this as a 2 to the power, 32 can be written as 2 to the power 5 into 2 to the power 20 kilobytes, which gives you 2 to the power 25 kilobytes. So that's going to be the first answer for the first one. So the second one, the request is converting 64 MB into the bytes, right? So again, the conversion goes like how? It goes from megabyte to kilobyte and then kilobyte to byte. So 64 will be taken as it is. So 64 megabyte to kilobyte. Kitmi, the last one. Yes. That of course correct. Right? Since it is asked from gigabytes, it's better you keep it as a gigabyte one. Right? Even your answer is correct, Dua. Right? So 64, to convert megabyte into kilobyte, we need 2 to the power 10. To convert kilobyte into byte, we need 2 to the power 10. Right? So that is going to be in byte. And the answer can be written as 64 into 2 to the power 20 bytes. 64 can be written as 2 to the power 6, 2 to the power 20 bytes, which is going to give you 2 to the power 26 bytes. Right. So the third one, they are asking to convert 2 to the power 26 bytes into megabytes. It's kind of the reverse situation of the previous math, right? So what are we going to do is we take 2 to the power 26 as it is. Journey is byte to kilobyte and from kilobyte to megabyte. So when we are converting byte to kilobyte, we need 2 to the power minus 10. Now it is minus values because it is going from a smaller unit to a bigger unit. And this is again 2 to the power minus 10. So which is going to give you 2 to the power 26 into 2 to the power 2 minus 20 megabytes, which equals to 2 to the power 6 megabytes, which means 64 megabytes. Right. The fourth one, the conversion is asking to convert you 2 to the power 30 kilobytes into gigabytes, right? So kilobyte to megabyte and megabyte to gigabyte. So 2 to the power 30 kilobytes to megabyte will cost you 2 to the power minus 10. Megabyte to gigabyte will cost you another 2 to the power minus 10. This is in gigabytes. So which means 2 to the power 30 into 2 to the power minus 20 gigabytes, which means 2 to the power 10 gigabytes. If you want to have it as a number, it is 1024 gigabytes. That means this is a 1 terabyte, right? But since I have asked the question in gigabytes, it's better you go with the gigabyte answer. Okay, people, is this clear?
Yes, sir. Yes, sir.
Great. One last question, since I couldn't take you to the bits over here. One last question, let's take it as the 5th one. So find this as well. We'll do 2, right? Find right, these 2 things. Now we know how to do this very quickly. So I'll give you like 2 to 3 minutes. And if you got any doubts regarding this, just let me know, people. Yes, Dilendia, that's the correct answer. Very good. Hold on, Dylan there. I'm sorry. There is a small mistake. It's going from bits to. So you have to consider about the conversion from bits to bytes as well. That makes you the trick. Yeah, kit me. That's the correct answer. Very good. And let me see. Yes. Yes, that's correct. That's correct. Hit me. And Utkarsha. Utkarsha, your second one is correct. Third one, it is having a little a mistake. I think it's the conversion between bits to bytes. Utkarsha, right? I'm sorry. I always messed with that, with your name, Dua. Right. So let me do this for you. So see whether you have got it correctly, people. Is there anyone who needs more time to do this? Okay. So the fifth one, it is about converting 2 to the power 35 bits into a gigabyte. Oh, Sanushi, I think something went wrong. Just see, Dua. Just see. I think there's a mistake, Dua. Hold on. Right. So the fifth one is all about converting 2 to the power 35 bits into gigabytes. Journey is a little bit lengthier. Bits have to become bytes. Bytes have to become kilobytes. Kilobytes have to become megabytes. Megabytes need to become gigabytes. Right? So this 2 to the power 35 can be taken as 2 to the power 35 as it is. Bits to byte conversion can be taken as 2 to the power 3, minus 3 actually. And bytes to kilobyte conversion, 2 to the power minus 10. Kilobytes to megabyte conversion, 2 to the power minus 10. Megabyte to gigabyte conversion, 2 to the power minus 10. Now you got the answer from gigabytes. So that means this gives you 2 to the power 35 into 2 to the power minus 33 gigabytes, which means 2 to the power 2 gigabytes, which means 4 gigabytes. People, did you get that? Yes, everyone? Right. Okay. Right. The sixth one says convert 128 megabytes into bits. Right. So if you think about the journey, megabytes will become kilobytes. Kilobytes will become bytes, and bytes will become bits. So 128, that can be taken as 128. Megabytes to kilobytes conversion, 2 to the power 10. Kilobytes to bytes conversion, we need 2 to the power 10. Bytes to bit conversion, we need 2 to the power 3. So it comes from bits, which means 128 into 2 to the power 23 bits, which equals to 128 can be taken as 2 to the power 7 into 2 to the power 23 bits, which means 2 to the power 30 bits can be taken as a single answer. Right? So that is the way that you are going to have the answer for the fifth and the sixth. Okay. I think it is pretty clear with you all now. Still, anyone who got any doubts regarding this? All right, so, okay. So I'll give you a minute. If you got any mistakes to be corrected, then after we are going to go to do the rest of the lesson. Okay, so let's go to the last part of the lesson. So let me have the note. Yeah, so we had these conversions and the bits and the byte thing. People, did we wrote about that capacities and cost per unit storage and all these things? Did we no, we didn't, right? We were just staying over here. I think we haven't came up to this point. Right, I think this is the last chart that we have drawn, the observation part. I did ask you to draw that, right? Just check whether it is the last one that we have drawn, people.
We didn't draw these observations.
We didn't draw that observation. Okay. So you just write about the bit byte nibble, and then you write about my chart. Likewise. Haven't we wrote about the bit byte and about the nibble as well?
No, sir.
We didn't. Okay. We straight away went to the conversions then. All right. All right. So let's go with this data storage capacity. So it's better you have this subheading, data storage capacity. And let's write about the bit. As well as the byte. And there is a forgotten unit. Forgotten unit means like now we are not using that a unit here, which is called the nibble. All right. We write about that as well. Then we'll go for that observation. Let me know when you are done, people. Okay, two are done. How about others? Anyone who is still writing? All right, so I'm moving forward. Let's write this. You don't need to write the word observation. You can write this. Then, like after petabyte, there is something called exabyte, as I remember. Yeah. Tera, peta, and exa. Let me search it and see, since you are asking. Yeah, so it says petabyte, exabyte, zettabyte, yottabyte, and brontobyte. They haven't went beyond that. Some funny names are there. Okay, are we done?
Yes, sir.
Right, okay. Anyone who is still writing?
Answer.
Okay, so moving forward. Yeah, and there was a small yeah. It's better you write this line under what you have written, people. In production of hard disks, their instances 1024 is considered as 1000. So that is just for the calculation purpose and the illustration is of the illustrations, right? So it's better you mention that. Okay, are we done?
Done, sir.
Right. Okay, so we are moving forward. Yes, now we have to talk about these capacities of data storage devices. This is something for you to buy hard, right? So, and some theory part in this lesson. So, capacities and data storage devices are categories like this. Now, regarding the data storage, they are talking about the different types of data storage that we can find in the computer, right? So they are starting from the registry memory, right? So the register memory is considered to be the smallest unit or the smallest memory unit that you can see, right? Which is inside the CPU, right? As well as when it comes to the cache memory, it's going to be the next biggest one. So the register memory is the smallest, cache memory is bigger than that, right? You can see it from the capacities over here, right? Then they have taken the CD and the DVDs, which are the secondary storage devices, which category under the optical storage. Then the RAM, right? Because the compact disc, they goes from 650 to 900 MB, and DVDs goes from 4.7 to the 9 GB. RAM, of course, you can find from 1 to 64. Sometimes it goes to 128 as well. And they have mentioned the ROM over here without any capacity. It is because like ROM differs from the very smaller portions to the bigger portions, right? So because of that, they have placed the ROM over here. Then the flash memories, hard disks, and the magnetic tape. That is the way the storage capacity increases from the smallest unit to the biggest. Yes, so yeah, Udan, I'll tell you what to be written. For the moment, just hear me out, right? So then they are comparing the access speed. Access speed means like how fast these particular memories can be accessed, right? So since register memory is inside the CPU, it has the highest access speed, right? This can be accessed in a very speedy manner, right? So access speed is higher means the time that it will take for the access will be less, right? Because the fastest one will spend less time to do a work, right? So registers memory has the highest speed, and then the cache memory, which is lower than the register memory. Random access memory is slower than the cache. Likewise, read-only, flash memory, hard disk, DVD, CDs, and magnetic tape decreases their speed of access on the hierarchy, right? So according to this, the slowest access speed has the magnetic tape. So access speed is slower means if you are going to read something from that memory, it will take more time. But when it comes to the modern computers, we won't feel it is very slow, right? Because what we are going to work with is this flash memories, hard disk, DVDs, CDs, not with the magnetic tape actually, right? So these four things, like out of these four, we have experienced that the flash memory is very faster when we are accessing something. Like think about that you are copying something from the flash memory or like a USB stick to your computer. It will copy it out very quickly. It is because it is being accessed speedily, right? If you are copying something from a CD, if you are copying the same thing from the flash and the CD, this will copy it as quickly as possible, right? CD will do it in a slower manner if it is the same file, even though it is the same file. Right, and the final comparison is about the cost per unit storage, right? So when it comes to the costs, this registry memory registry memory is inside the CPU. So like you can't buy registry memory separate from the market. So if you want to buy a registry memory, you have to buy a CPU. Same goes with the cache memory, right? So CPU will cost you around 40 to 50,000, right? Which means it is very expensive. Random access memory, you can buy that for like 10 to 15,000. Read-only memory, actually here, they are talking about a small, not about a small ROM, like something which is, which can contain a bigger capacities, right? Like if you think about a particular read-only memories, it goes with some big amount of data. So again, you can buy this for 6,000 to 7,000. Magnetic tape will give you the same kind of cost, but it is bigger in capacity. When the read-only memory gives you 3 to 4 GBs, magnetic tape will give you 30 to 50 GBs. So cost per bit will be lesser in the magnetic tape. Flash memory, like you can take like 4 GB of flash memory to 4,000 to 5,000, right? When you are spending 4,000 to 5,000. Hard disk, again, how much? 1 terabyte of capacity can be taken to like 7,000 to 10,000. So cost per bit is lesser. DVD, digital versatile disk, how much? Like 4 GB will cost you like how much? 40 rupees, right? So that is the lowest cost per bit that you can find, right? So it's better you remember this order, right? So it will be easier for you to answer some of the MCQs, right? Because they ask like what is the arrange the storage into the ascending order according to the cost per bit, or they will say arrange the storage into the descending order according to the access speed. Likewise, so it's better you remember which has which quality. Right, so regarding the writings, yeah, we'll write it like this. So you can have these capacities of data storage, and you can copy the list. Right, you don't need to draw these elephants and ants. It's better you indicate that the word small and the word large with the arrow as well, right? So it will be easier to understand. Right, so have the heading capacities of data storage devices, then copy the list. Yeah, Udan, hold on. There you go. Okay, one is done. How about others? Can we move forward? Anyone who is still writing?
Done, sir.
Right, okay. Right, so moving forward. Data access speed. Again, you have to go with the this particular chart. As well as the fast and slow words and the arrow. Okay, one is done. How about others?
Done, sir.
Okay, anyone who is still writing? Okay, Senetma. Let me know when you are done. Right, so let's move forward. Here we go with the cost per unit storage. right? Goes with the comparison as well, people, as well as this high and low ends plus the arrow. Okay, one is done. How about others? Okay. Anyone who is still writing? Right. So moving forward, then we are there to talk about the coding systems, right? So first of all, you have to understand why we need a coding system. And I think you know now, like when during the lesson, all the calculations and all these binaries and all these things we learn, it is because to understand how the data is represented in computer. Right now, when it comes to the when we comes to the root of the computer data representation, we can find all the data are being introduced into the computer as a 1 and a 0 sequence, right? As this picture illustrates to you, it doesn't matter whether it is a number, whether it is an icon, whether it is a text, right? Whatever the thing, whether it is a symbol, right? Everything represents as a 1 and 0 sequence, right? We don't know how much or how many of things are used to represent an image kind of a thing, because image is kind of a complex component when it comes to the computer. But for sure, in nowadays, a character, right? A character that you can find in the keyboard is use 16 bits. That means 16 ones and zeros, some particular ones and zeros of the 16 ones and zeros will be used to represent one single letter or one single character of the keyboard, right? So in early days, back in early days, this keyboard as well as the data which was inserted into the computer were not that complex, right? The computer was made at the first place, they were made for solve the complex mathematical equations or like the mathematical problems, right? So they were like crunching the numbers, right? They were working with the numbers only on those days. So in that case, in that era, the computer scientists had the challenge of to represent a particular number in the computer, right? So it was only about the numbers, right? So since the people or like since the humans are working with numbers of zero, like in decimals, like which has the 10 different characters, which is 0, 1, 2, 3, 4, 5, 6, 7, 8, and 9. They only need a solution to represent these numbers or characters, which represents 0 to 9, right? By using the characters from 0 to 9, you can represent any particular number. Now we know that, right? Things can be repeated, but still, if we have those 10 characters, we can represent any particular number. So as a solution for this, what they had done is they had introduced something called BCD, binary coded decimal, and they represent one particular character as a 4-bit code, right? So what they have done was they take this code and they have these place values like 1, 2, 4, and 8. So to represent 0, they write it as 4 zeros. To represent 3, they need 1 and 1 over here. So 2 zeros comes over here. To represent 6, this one, 4 and 2 need to be represented, and other things are 0. So likewise, their attempt was representing a number into the computer using a 4-bit code, which we call binary coded decimal. Now, the problem arises when the computer get advanced and it is there to absorb letters and numbers both into the computer. Because using this 4-bit code, the maximum that you can represent is just 16 different characters, right? So like you can represent 16 different things from a 4-bit code, right? But if you think about the English alphabet, from capital A to capital Z, there are 26 characters. To simple A to simple Z, there are another 26 characters. From 0 to 9, there are 10 characters, right? If you think about only these things, it will give you how much? 62 different characters to represent. So to represent 62 different characters, they need 62 different combinations of ones and zeros. So BCD value was not sufficient, right? Because it was made to represent only 16 different characters, right? So because of that, they introduced something called Ascii code, right? So Ascii code, it was introduced as a 7-bit representation method. That means one particular character will be represented using 7 ones and zeros, right? So 7 ones and zeros has given the ability of naming 128 different characters in the computer, which was quite easy and the requirement was fulfilling. And later, again, with the advancement of the computer, this particular device has improved to represent different kinds of languages with different kinds of symbols. So again, there was a problem of 128 characters, because when some particular languages are introduced, it goes beyond the 128 characters. So as a result, or as a solution for that, they have introduced another coding system, which is called EBCDIC, Extended Binary Coded Decimal Interchange Code. So that gives you, it is a 8-bit representation, 8-bit representation, which gives you to identify 256 different characters. But the problem was, if you think about the last 2 decades, the computer was like growing in a random and a very rapid manner, right? Which introduced many different languages, many different characters, many different images, colors, sounds, videos, lots of things. So 256 different characters surely were not sufficient to represent that kind of complex combinations. So what they have done was they have introduced something called Unicodes, right? Unicodes, which obtain or which include 16 different characters inside it. So with these 16 different characters, so like 16 different bits represent one particular character. So like these 16 bits code has the ability of representing 65,536 characters to the computer, which is sufficient, seems to be sufficient for the moment. But I'm very sure in near future, we have to go for another new coding system, because still computer is growing, right? So regarding the coding systems, all you need to remember is what kind of, or how many number of bits were used to represent these kind of coding systems in these kind of coding systems, as well as in next week, I'll show you how to represent a small number from the BCD, as well as when it comes to a particular word, how we can use the Ascii code system to represent that small word, right? And by next week, for sure, we will be able to finish this off, and I will start in the 4th lesson as well, right? Because it's a small part that we need to go through, right? Then we'll move to the 4th lesson, which is the logic gate, right? So today I will end the session from this point. So thank you very much, everyone. I will see you on next week for the very same time, right? Okay, people, have a very nice day. I think it is over now. So have a very good night, right? Thank you very much, people. I'll see you on next week.
A very good night.
Goodbye.
Thank you, everyone. Thank
Everyone,
you.
sir.
Goodbye. Right, okay, people.
Thank you, sir.
Right, Dua, thank you.